Algebra 1. Today we're going to do 2.6, which is called literal equations. I absolutely love this section. So literal equations are just normal equations that have only variables. And so we solve them the same way that we do other equations, but your answers are not going to simplify as nicely as we're used to. All right, so literal equations, the definition is equations with multiple variables. And I'm going to show an example on the left of a math problem that has numbers, and then the problem on the right has only variables. So if we were solving the problem on the left, we would know to add 5 to each side. From there, we'd have 2x equals 18. We divide by 2. And x simplified to something really nice and neat of a 9. The problem on the right is the exact same process, but now you're not going to get a number as an answer. So, if I'm solving for the variable x, which is right here, I'm going to treat it the same way. I'm going to add b, that's b, to each side. C and b are not like terms, so I cannot combine them. So I'd write c plus b, and then I'm going to bring down my ax. The a is being multiplied by x, so I'm going to divide each side by a. And then my answer becomes x equals this whole thing, c plus b all over a. So some similarities that you might notice, and it's underneath, it says both use opposite operations to solve. So we added on each side and then we divided. The only difference is the literal equation doesn't simplify nicely due to there being only variables. So we're going to run through some examples of these. So one-step problems are on the bottom, and it tells us which variable to solve for each. So I'm going to focus more on the right side of the examples, and then I would like you guys to be doing filling in the ones that I did not do. Okay, so for number 2, zoom, it says to solve for h. So if a is being multiplied, or a equals b times h, then that would mean I have to use division. So if I'm solving for h, it's right here. B is being multiplied, so I am going to divide each side by the variable b. B's cancel, and you're left with h equals a over a lowercase b. And that's it. Same with 4. Now I'm going to be solving for the variable t. All of this is being multiplied, p times r times t, so I can do this in one step, and I can divide each side by pr. P's cancel, the r's cancel, and I'm left with t equals I over PR. Oops, that's an I. Number 6, we're going to solve for r, and you'll notice that it's r squared. So for number 6, we are going to, all of this is being multiplied, so I'm going to divide each side by pi. Pi cancels, and I'm left with r squared equals a over pi. To get rid of anything squared, you can take the square root of each side. By doing so, r is alone, and your answer is going to be the square root of a over pi. Number 8, we're solving for m, which is in the numerator. So to get that alone, you have to take whatever's in the denominator and multiply it on each side. So we're going to times that side by v and this side by v. The v's cancel, and we're left with m, sorry, my marker, we're left with m equals d times b. Okay, moving over to number 7, we're solving for c. So my first step is to add s. And so my answer is m plus s. Okay. Hopefully one step is not too difficult. I would like you guys to finish these for tomorrow. And then we have to go on to the back page. So we have multi-step problems, and there's helpful hints at the top. This is think backwards, remove fractions by multiplying by the reciprocal, and then lastly we're going to divide whatever is next to our variable. So I'm going to jump to number 10. Number 10 has 1/3 times the base times the height. So whatever's in the denominator, I'm going to multiply first on each side. Okay. Then I have 3b equals, b's cancel, and we're left with bh. I'm solving for b, so I need to undo the multiplication by dividing, and my answer equals b equals 3b over h. Okay, number 12, we're going to solve for b. So first we have to get whatever's out of the denominator and move it to the top. So I'm going to multiply each side by d. This stuff cancels, and we have dA or AD, however you want to write it, equals b plus c. I'm solving for b, so I need to subtract c to get rid of it. And I am left with dA subtract c equals b. Okay. Let's keep going. Number 14 says solve for y. So that's right here. So my first step would be to subtract ax. Ax is canceled, so we're left with by equals, and again, c subtract ax, just rewrite it. We're solving for y, so you divide each side by b. And so y equals that whole problem, c minus ax all over b. 16. Now we're solving for the variable d, which is over here. First step, subtract p. So then you have a subtract p equals PRT. PR and T are all being multiplied, so I'm going to divide by PR. They double cancel, and we're left with, again, this whole thing, A subtract P all over PR. Okay, a problem that's more difficult will definitely be numbers 17 and 18. Let's do 17. We have 5/9 times the stuff in parentheses. This is the formula for Celsius. Whatever is in this front part, we are going to do the reciprocal because we're solving for f. So my first step is to multiply each side by 9/5. When I do that, my fractions cancel, And then I'm left with 9 over 5, 9c equals f subtract 32. I'm solving for f, so I would add 32. So my answer is the fraction 9 over 5c plus 32 equals f. Lastly, we have area equals half of the height times base 1 plus base 2. Another formula you're going to see next year in geometry. So I'm solving for base 1, which is b1. My first step is to get rid of the fraction, so I will multiply each side by 2. 2 times a is 2a. My fraction cancels, and I'm left with h times b1 plus b2. Okay, to get rid of the h, you're going to divide, and now my h's cancel. So 2a over h equals b1 plus b2. Still solving for b1. Because it's plus b2, I'm going to subtract it. We know this cancels, and my answer would be, and I ran out of room, b1 equals 2a over h subtract b2. Okay? What I want you guys to do tonight is finish up some of these problems. So I want this whole page to be completed by tomorrow, and bring your questions tomorrow, okay? So questions. I ran out of room there. Ask tomorrow. Please. You have a quiz on Monday, and this will be on it. Okay, you guys have a good night.